How does a qubit work in quantum teleportation? Imagine being able to send the exact state of a tiny quantum particle across space without moving the particle itself. Sounds like magic, right? But this is actually how quantum teleportation works, and at the heart of it is something called a qubit. A qubit is the quantum version of a regular bit, which is the basic unit of information in computers. And like a regular bit that is either 0 or 1, a qubit can be both at the same time. This strange property is called superposition. It means a qubit can hold multiple possibilities until measured. Now, quantum teleportation isn't about teleporting objects or people. It's about transmitting the state of a qubit from one place to another. The process begins with two qubits that are linked in a special way called entanglement. When two qubits are entangled, whatever happens to one instantly affects the other, no matter how far apart they are. This spooky connection is what makes quantum teleportation possible. Suppose Alice wants to send her qubit state to Bob. Alice has her qubit in an unknown state, maybe spinning up, down, or both at once. She also has one half of an entangled pair, while Bob has the other half. Alice then performs a joint measurement on her original qubit and her half of the entangled pair. This measurement destroys both qubits, original states, but creates a link between them. The result of this measurement is two classical bits of information, which Alice sends to Bob through regular communication like email or text. These bits tell Bob what operation to perform on his qubit. Once Bob receives the classical bits, he applies a specific operation to his qubit. After this step, Bob's qubit is now in the same state as Alice's original qubit was before the measurement. The original state on Alice's side is gone, but it has been transferred to Bob's qubit. This process relies on the no-cloning theorem, which states you cannot copy an unknown quantum state. Instead, the state is destroyed in one place and recreated in another, making the process truly unique. This whole setup is what makes quantum teleportation so fascinating. It uses entanglement, measurement, and classical communication to move quantum information across distances. It's not about instant travel but about transferring quantum states securely and efficiently. This technology is already being tested in labs and could lead to future quantum networks, where information is shared with perfect security and incredible speed. In essence, a qubit in quantum teleportation acts as a carrier of quantum information. It's manipulated through entanglement and measurement, allowing its state to be transferred from one location to another without physically moving the particle itself. This strange process opens up new possibilities for future technologies and shows how weird and wonderful the world of quantum science really is.